Okay, Assalamu alaikum everyone. So today we are going to start with organic chemistry. And we are going to discuss the basics of organic chemistry. So it's really important to understand those basics. Okay, so if you want to define organic chemistry, we can define it as a study of hydrocarbons and their derivatives. Okay. So when we talk about hydrocarbons, we are talking about actually those compounds which have only carbon and hydrogen. Assalamu alaikum, Ahmed. Okay. So hydrocarbons are compounds containing carbon and hydrogen only. So, okay. And when we talk about derivatives, so these are the compounds which are derived from hydrocarbons. What does it mean? It means that when the hydrocarbons reacted, they undergo reaction, they turn into these compounds. So these are derived from the hydrocarbons. And the important thing about these compounds is that they just not contain carbon and hydrogen only. They contain or they have other elements which are halogens, oxygen, nitrogen, sulfur, etc. Along with carbon. Is this clear? Okay. So when we talk about X, so X are actually halogens, which are fluorine, chlorine, bromine, iodine, etc. So these are the compounds which we call halogens. Okay. So organic chemistry, the study of hydrocarbons and their derivatives. So I am sure now you guys have understand the difference between the hydrocarbons and their derivatives. Okay, now if you see, one thing is common, whether it's a derivative or it's a hydrocarbon, there is a carbon always. Okay, so when you look at a carbon, so what you are going to observe that carbon has 4 valence electrons, right? And if carbon has 4 valence electrons, then it means that, and that's what you need to remember, that it always form 4 covalent bonds. Okay, so carbon always form 4 covalent bonds. Okay, so basically all organic compounds, when I say all organic compounds, it means I'm referring to both hydrocarbons and their derivatives. So they all have a basic structure or the basic skeleton of carbon atoms joining with each other. So all organic compounds have basic structure or skeleton of carbon atoms bonded with each other due to a property called catenation. Does anyone know what does catenation means? Yes, Ridwan. Yes, Mariam. Ahmed. It's not cation, see? Yes.
Sir, the ability
Hmm?
to make the ring structures. The ability to make ring structures.
Not ring structures, the ability to make a wide variety of structures, as carbon can bond with itself in a multiple ways. For example, how many bonds an oxygen atom can make? 2. But did you find that oxygen is bonded like this to make a long chain of oxygen atoms? How many bonds nitrogen atom can make? 3. But did you ever find that the nitrogen atoms bonded with each other to form a long chain? Right? But you can see a carbon atom bonded to each other to form a long chain or a branch chain or a ring structure. So that's what we call catenation. So that property is exhibited by carbon. And after carbon, silicon do exhibit the same property, but with the lower extent because of its a bigger size or bigger radius. Okay. So what does catenation refers to? It refers to a formation of wide variety of structures due to no, not due to, as carbon atoms bonds bond with each other to form or with each other in multiple ways. And that multiple ways includes long chain structures, straight chain structures, branch chain structures, cyclic rings, having a double bond, single bonds, triple bonds. In these multiple ways, means unbranched, long chain structures, branched, chain structures, and cyclic or ring structures. I hope it's clear. Yes, Ridwan and Laiba.
Clear, sir.
Okay.
Yes, sir, clear.
So how can we figure out the structure is a straight chain or not? But how could you figure out that, yeah, it's not branched and it's a straight chain structure? Hmm? Okay. So if I initially categorize the structures of a carbon, who is unknown? Yes. Assalamu alaikum. Can you please write your correct name? Okay, I was also thinking in the morning, cancel the class. Okay. Okay, so we have a three, initially we can categorize the structures into three different types. These includes first, unbranched, chain. Second include branched chain. And third include, we can say closed, cyclic, or ring chain or ring structures. So these are the three categories of the structures. Okay. So, 1 minute. So I'm drawing a structure over here. Yes, so can anybody tell me that whether this structure is unbranched or branched? Yes, Ahmed. Okay, Mariam is saying unbranched. What about the rest of the students? Yes, Ridwan, is it branched or unbranched? Laiba, unknown.
Branched.
Ahmed, yes, there is some. Yeah, but students always get confused in this. Yes, good. So, but how can you figure out? Yes, you are explaining me and you know, but if you need to explain to someone, how could you explain, yes, that it's not straight, it's a straight chain, it's not branched? Yes, if you need to explain to unknown how it is unbranched.
सर डबल बॉन्ड नहीं है.
Okay. Yes, 1 minute. Laiba, what you were saying?
डबल बॉन्ड नहीं है.
Sorry?
आई एम सेइंग तो सर डबल बॉन्ड प्रेजेंट नहीं है.
No, it doesn't matter. Straight chain also have a double bond as well. There is nothing to do with the straight chain or branch having a double bond. Okay. So one thing that you need to remember for this, that each carbon is bonded to maximum two more carbons. If you find this thing in the structure, then it is always a straight chain or unbranched structure, whether it is, jumbled like this or it is drawn in the straight way. So if you see in this structure, the first carbon is having a one bond only with the carbon, this carbon having a one bond only. But if you look at the any other carbon, that is bonded to two carbons. If you look at this one, if you look at this one. So maximum, if in a chain, if a carbon is bonded to two more carbons, then that structure is always considered as a straight chain structure, whether it's drawn straight or not. Is this clear? See. Yes, Ridwan, Laiba, and unknown. Is this clear?
Yes, sir.
यस सर.
Okay. Now, the branch chain structure. So, for example, if I draw it like this, then is it a straight chain? Right? So, why it is a straight chain? Because there are carbons which are bonded to one more carbon or maximum two more carbon. That's why it's a straight chain. But for example, if I put a carbon over here, so this carbon is now bonded to three carbons. That makes it a branch structure. So that is the rule to identify a branch structure. There must be at least one carbon which is minimum bonded to three carbon. In some cases, a carbon can be bonded to four carbons and more. For example, like this. Is this clear? Okay. So at least one carbon is bonded to minimum three carbons. That's what a branch structure is. So it means there is a possibility that there is a one carbon which is bonded to four carbons in the branch structure. So the minimum requirement is this, that at least one carbon which is bonded to 3 carbons, then that structure is always considered as a branch structure. Is this clear? You guys are playing something? Okay. So how can you figure out a closed chain structure? 5. No. No. No, you are wrong. For example, if I draw this structure, see, it's a ring structure is there, but there is a one carbon which is bonded to only one carbon. So there are two types of cyclic structure. One is this one. For that, your statement is correct. But these are also considered as a cyclic or ring structure. So how can you define or figure out the ring structures? That each carbon is bonded to 2 carbons at least, unless there is a branch. So in the first case, there is no branch, so you can find every carbon is bonded to 2 carbons. And it's not necessary to write at least. Okay. So in the first case, each carbon is bonded to 2 carbons. So that makes it cyclic. And in this case, there is a branch. So for a branch, it's not necessary the branch chain that each carbon is bonded to 2 carbons. Yes, is this clear to all of you?
Yes, sir.
Okay. Now, Ahmed, is it hydrocarbon? So what does it called? But it's not a hydrocarbon. Yeah, it's a derivative because it has another element beside carbon and hydrogen. No, that is ether basically. So if we have this structure, so if I complete this structure, so yeah, I can consider this one as a hydrocarbon. Okay. So this one is not hydrocarbon because there is a one more element except hydrogen and carbon. And this one is a hydrocarbon. Okay. So the next thing that is really important, and that's what you need to remember, that how many bonds each of these elements can form. So we have a carbon, we have nitrogen, we have oxygen, we have halogens, and then we have hydrogen. So halogen means fluorine, chlorine, bromine, iodine, etc. Okay. So carbon make 4 bonds, and these bonds, always remember that these bonds are covalent. Okay. So carbon make 4 bonds, nitrogen make 3 bonds, oxygen make 2 bonds, halogens and hydrogen 1 bond. Is this clear? So these are the things that you guys need to remember. Okay. Now, what is the major source of hydrocarbons? It's the source of carbon. Yes, blast furnace. We extract iron in the blast furnace. But what is the major source of hydrocarbon? Yes, Laiba, Ridwan. Crude oil, fossil fuels. Yes. So the major source of hydrocarbon is fossil fuel, crude oil. Okay. So we will discuss it in cracking that how the crude oil is undergo fractional distillation to get the different fractions, and the long fractions, the bigger fractions can be undergoing cracking to get the smaller fractions which are more useful. Okay. Now, for example, if I give you guys a task, let's suppose it's C2H6O. Draw the structure depending upon the number of bonds, as we have discussed that carbon have 4 bonds, nitrogen have 3 bonds, oxygen have 2 bonds, and hydrogen and halogens have 2 bonds. 1 bond, sorry. So everyone draw the structure. The students which are online, you guys can WhatsApp me quickly after drawing the structure. Ahmad, where is your notebook? Okay, let me check. Yes, Ridwan, Laiba, and the unknown one. Take another structure from this formula. Yes, Ahmad. Wait. The online one, I'm not getting any response. Can we make any other structure from this formula? Draw. Any other possible structure from C2H6O? Yes, Laiba. Yes, Ridwan, I'm waiting. What I know, he just you need to draw the different structure. What is the difference between this? You are making the same. There are only 2 carbons. The right carbon. Wait. Or on the left carbon. He knows. Okay, draw. Yes, Ridwan, Laiba.
Sir, sending on WhatsApp.
Okay. So the one possibility is this, that a carbon is bonded to another carbon, right? And that carbon is bonded to O, and then O is bonded to A. So if you look, we are done with all the bonds of oxygen. Oxygen can make 2 bonds, and we made the 2 bonds. If you look at the carbon which is between oxygen and carbon, how many bonds it has? 2. So a carbon atom total makes the 4 bonds. So yeah. Okay, very good, Laiba, but you missed the bond between oxygen and hydrogen. The rest is fine. Okay. So the carbon in the middle get 2 more hydrogens because it can able to make 2 more bonds. And the carbon which is on the right side has 1 bond. So it means it can make 3 more bonds. So it will get 3 more hydrogens, right? Okay. So that's what we got, one structure of C2H6O. But what we did here, that we put the carbon, then oxygen. So if instead of this, I just rearrange these carbon and oxygen, like you can see, if I put a carbon, then oxygen, then carbon. So again, if you look, how many bonds oxygen atom have? 2. So oxygen cannot bond with anything else. Each carbon has now 1 bond, and we know each carbon can make total of 4 bonds. So in this case, carbon can make 3 more bonds. So if you see, yes, I know. So if you see, they both got the same molecular formula, isn't it? But their structure formula is different. So see, this is the another reason that carbon can make a variety of compounds. You can't see this thing that the same formula with a different structure for any other element, but for carbons. So, if you count all the compounds formed by all the elements in the periodic table, the compounds formed by carbon are way more than that. Only carbon can make so many compounds that the compounds of the carbon, the number of the compounds formed by the carbon are greater than the total number of the compounds formed by all the other elements. Okay, so now, so if you look at these 2 structures, what we are observing in these 2 structures, now just close that, switch off. Okay, so in these 2 structures, both structures can comprised of 2 carbons, right? So if the structure on the left has 2 carbons, so isn't it that the another compound may exist with the 1 more carbon? Is there any possibility like this, that right? And if there is a 1 compound of a 3 carbons, so there is a possibility that there is 1 more compound with the 4 carbons as well. Right? So if you see in all these 3 structures, there is one thing is common. And what is common? The OH atom, right? In all of them, there is a OH which is common. So that OH is considered as the functional group. Is this clear? So similarly, if we have a one compound over here which has two carbon atoms, so there might be, and there is a possibility there is one more compound like this which has three carbons, right? Yep, very good, Mariam. C, and then one H here, one H here. And then there is another possibility that there must be a compound having the four carbons with the same structure. So see, and now if you look over here, so what is common over here? COC is common. Right? So this is the functional group over here. Okay. Yes, Laiba, Ridwan. Is this clear to all of you?
Yes, sir. Yes.
Yeah. Okay. So I can mark this thing as functional group. So the structures which are on the left, they all have same functional group, right? And the structures which are on the right, they all have also the same functional group, right? So if you look at the structure on the left, if you work on its general formula, so you will find that they all compounds following the same pattern and the same general formula, which is CN H2N plus 2O. Or it is CnH2n plus 1 OH. There are two ways to represent the general formula, CnH2n plus 2O or CnH2n plus 1 OH. So this one also have a same general formula, right? But the thing is that these three compounds have a specific functional group, which is OH. And these three compounds have a specific functional group, which is COC. So these three compounds have a same functional group. They have a same general formula. So it clearly indicates that these three compounds behave chemically in a same way. They react in a same manner. So it means their chemical properties are also present. So that's why they all are considered as one family of a compound or a one homologous series. Okay? No. So it is one family of compounds right? It's a family of a compound. Is this clear? So similarly, this one is also a family of a compound because these structures have a same general formula. Okay, so all of these have same general formula. They all have a same functional group. And as their functional group suggests that they are going to behave in a same chemical manner, right? So these three also belongs to a one family of a compound or one group of a compound. Is this clear? Any confusion so far? Okay. So on the basis of that, so this is called homologous series. The synonym for a group of a compound or the synonym for the family of a compound, we call it homologous series. So over here on the left side, we have a, let's say, homologous series 1. And on the right side, we have another group of compounds who have a same molecular formula, sorry, same general formula, same functional group, and same chemical properties. So that is considered as homologous series 2. Is this clear to all of you?
Yes, sir.
Yes, sir.
Okay. So we are going to write the definition of homologous series because examiner can ask you what is homologous series. So we can say it's a group of compounds. Yes. Having same general formula. What else is same?
Similar physical.
Not physical. General formula. Same functional group. And what else is same? Yes, and same chemical properties. So those compounds which have these three things in common, so we consider them, they are from one group of compounds or one family of compound or a one homologous series. No, they changes gradually. It's not similar. The melting point changes. As the chain gets longer, the melting point becomes higher and higher. As the chain gets increases, the solubility differs, the density differs. So they changes gradually. So they are not, we can't say they are similar. Is this clear? Okay. Now, what is the difference between the each or among the members of this homologous series? And in terms of mass, 12, the difference is of 14 units. And in terms of a structure, every next member have CH2 greater than the previous one. So each next member contain a CH2 unit more than previous member and has 14 mass units greater than previous member. Let's see. Due to the E. Okay, so have a look over here. If you see, if you move from here, from the first to here, you can see there is one more CH2. If you move here, there is again one more CH2. and CH2 has a mass of 14. So every next member has a 14 mass greater than the previous one. And in terms of structure, one more CH2. You can look over here. See, there are two CH3s, and over here there is one CH2 which is not in the previous structure. There is one more CH2 over here. There is only one CH2 over here. In this structure, there is two CH2. So see, every next member have a one more CH2, and the 14 mass is greater than the previous one. Is this clear? Okay. Now, next we have functional group. So as we have discussed that this OH is the functional group, and over here, this COC is the functional group. So how can we define a functional group? An atom or group of atoms which determines not only chemical but physical as well, which determines the physical and chemical properties of compounds, compound or molecule. See, for example, there is a OH. So a H is bonded to O, right? So due to this, the alcohols can form a hydrogen bonds, and there is no O bonded to H. So there is no hydrogen bonding over here. So if they forms a hydrogen bond, so their melting point and boiling point goes higher than these one. So see, it is also not only just chemical properties, is also these the functional group are also determining the physical properties as well, and the chemical behavior that this H can react with Na. But so that is the chemical property. Yes, it can react with Na because the H is bonded to O. It can react with the sodium metal. But as in this structure, no hydrogen is bonded to oxygen, so it doesn't react with sodium metal. So the functional group is the one which determines both the physical and the chemical properties of the compound. That's what we call functional group. Is this clear? Okay. So one, two, three, four, one, two, three, okay, so we are going to make a table. So we are going to get the introduction of all the homologous series that we will be studying in AS organic chemistry. Okay. So over here we are going to put the name of homologous series. Then over here we are going to put the functional group in that homologous series. Then general formula. So general formulas and general names are very important. If you remember the general formula and if you memorize it, then it will be very helpful for you to draw the structure and take out the molecular formula from those. And the last one is structure. Yes. Okay. So the first homologous series, yes. What is the first homologous series? Alkane. Functional group? No functional group. Because in alkanes, there is a carbon and hydrogen single bond, and that thing is found in every structure. No, alkene has a carbon-carbon double bond. That is the specificity in alkene. But that is all that is present in all the structures, isn't it? So that's why in actual there is no functional group. CN H2N plus 2, the general name, alkane. Okay. And structure. Structure means just a carbon with the single bonds and carbon with the hydrogens. And all are single bonds. Yes. Is this clear? Yes. Laiba, Kirsha, and Ridwan, is this clear?
Yes, sir.
It's Kirsha. Okay.
Yes, sir, clear.
Yes, Ridwan.
Clear, sir.
Okay. Now next we have alkene. So the double bond, a functional group is a carbon-carbon double bond in the structure of the alkene. And the general formula is CnH2n. What is the general name? Alkene. Okay. That is 2 carbon. Okay, so one minute, let me draw the structure of both alkane and alkene. So in alkane, there are all single bonds. And there are only 2 elements, carbon and hydrogen. In alkene, there are again only carbon and hydrogen, but there is a double bond. and double bond is the functional group. So over here, this part is the functional group. Okay. Then what is the next homologous series after alkene? The next homologous series is haloalkane, or also called halogenoalkanes. Okay. So what is the functional group over here? That in the structure, there is a halogen. Why I'm talking about functional group. So X is bonded with the carbon chain. So that X can be fluorine, chlorine, bromine, iodine. Okay. Now what will be the general formula? CnH2n plus 1. Well, that's it. Then X as well, because there is a halogen over there. Okay. Yeah, substitution of an alkane. Then we have haloalkane. Okay, that is the general name. Now, if I draw the structure, so the structure would be like this. For example, everywhere in the structure, there is a hydrogen. But with one carbon, there is a one halogen bonded to it. I'm just writing H, which means it can be X. I'm just writing X, which means that it can be fluorine, chlorine, bromine, iodine. So this is the functional group. I have encircled the functional group. Is this clear? Okay. Now after halogenoalkane, the next homologous series that we will be studying is, yes, Mariam, what will be the next homologous series? Yeah, alcohols. Yeah, we can write anyone. Okay, so the next one is alcohols. The functional group in the alcohol is OH, which is called hydroxyl, is bonded to a carbon chain. So the empty bond on the left is showing that it is bonded to a carbon chain. The general formula. So alcohol's got two general formulas. One is CN H2n plus 2O, or CN H2n plus 1 OH. The general name for alcohols would be alkanol. Yep. Alkanol. Okay. So if I want to draw the structure, I will take this whole thing. So the whole structure must contain a OH group. So that is the hydroxyl functional group, which is alcohol. Yes, is this clear to all of you? So the important thing why I'm discussing all of these over here, it is because, that is really important. When you look at the structure, you can find, yeah, this structure contains these functional groups. So that is really important, okay? Ahmad, be focused. Okay. So the next homologous series is what we called carbonyl. Yeah, we will discuss carboxylic acid as well. So carbonyl actually categorized into two further homologous series. There are two types of carbonyls. One are called aldehydes and the other one are called ketones. Aldehydes, remember, so that aldehydes are carbonyls, ketones are carbonyls. They both are carbonyls. So what is the functional group over here? In aldehydes, you will find a C double bond O that is actually called carbonyl. C double bond O is called carbonyl. Let me write it over here that a C double bond O, that is what a carbonyl is. Okay. So C double bond O, if that is bonded to H, and in the short form, it is written like CHO. So you need to be familiar by both the ways. You can't write it COH in the condensed form or in the structural form because OH makes it alcohol. And the other one is CO. It must be in the middle of the chain. So it is in its condensed form or the structural form, it is CO. Okay. So the interesting thing is that they both got the same general formula. That is CN H2NO. Okay. And then their general name. So the general name of aldehyde is alkenyl, and the general name of ketone is alkanone. Yeah, alkenyl, alcohols, alkanol, aldehydes, alkenyl, ketone, alkanone. Yep. So see, all means OH, L means C double bond O bonded to H, and non means C double bond O in the middle of the carbon. Yeah, L got the number of carbon chain. Yeah, number of carbon. It can be replaced depending upon the number of carbon, like meth, eth, prop, but, pent, hex, hept, oct. Yep. Okay. So if I want to draw their structures, just let me complete this. Just I want to complete, this part, all the homologous series discussion, then you guys can leave. Okay. So see this double bond O in the middle, that makes a ketone. That is the important thing. And over here, that the C double bond O, the carbon bonded to hydrogen. So if I need to underline or encircle the functional groups over here, so over here, this whole thing is an aldehyde functional group. Okay. So this is the functional group over here. And this is the functional group over here. Yes, is this clear to all of you? Yes, Kirsha, Laiba, and Ridwan.
Yes, sir.
Okay. Now after this, the next we have carboxylic acids. Yes. Carboxylic acids. So the functional group in the carboxylic acid is a C double bond O, but that C double bond O is bonded to a hydroxyl group OH, or it can be written as COOH, or it can be written as CO2H as well. Okay. The general formula. CN. Okay, it also got two general formulas. First one is CN H2N plus 1 COOH. Okay, there is a one limitation with this general formula. And what is that limitation? That in this general formula, for example, if I'm saying butanoic acid, then how many carbon it has? 4. So N is 1 less than total carbon. So for butanoic acid, if I'm using this general formula, I'm going to use the value of N as 3. Okay. So N is 1 less carbon than total carbons. Okay. Then the next general formula that we have, no, CN H2N O2. Yep. The general name is alkanoic acid, and if I need to draw the structure, so a C double bond O bonded to a OH. So that is the structure. Sorry. So this is the functional group in this. Yes. Is this clear? Okay. Now, the next that we will be discussing is esters. Then we are going to discuss amines, and specifically, we will be discussing primary amines. Please, then the next functional homologous series is amide, and the last one is nitrile. Wait. So what is the functional group of ester? Sorry? Yep. COO, very good. You said COC. So C double bond O, and that O must be bonded to C. So basically, the functional group is this part. And the O must be bonded to a further carbon, because if it's not bonded to a carbon, then it must be bonded to a hydrogen. That makes it carboxylic acid. And on the left side of a carbon, which has a double bond with O, it can be hydrogen or oxygen, it doesn't matter. Okay. So in the short form, it can be written as, yep. Hmm. Hmm. Yep. Yeah. Yes. Yeah, actually, it has three, no, I think 5 chapters. There are 5 chapters in organic. It's not one chapter. Okay. So the general formula is exactly the same as the general formula of carboxylic acid, the second general formula, CnH2NO2. And what will be the general name? Alkyl alkanoate. So the structure would be a C double bond O, and that C double bond O is bonded to a oxygen, and that oxygen is further bonded to a carbon. And over here, it doesn't matter. It can be H or C. Anything can be there. Okay, 1 minute. H or C. Anything can be bonded to the carbon double bond. Yes, still here, is this clear to all of you? So in this structure, if you need to encircle the functional group, so remember this is the functional group. This part, C double bond O and then CO. Okay. Next we have primary amines. So primary amines is the nitrogen bonded to a carbon chain, and that nitrogen is further bonded to 2 hydrogens. It is like NH2. And when we talk about amides, yes, what is amide, Mariam? Yeah, peptide, or it can also called peptide. It is a C double bond O, and that is bonded to a nitrogen having hydrogens. Yeah, so that is monosubstituted amide. Instead of these hydrogens, if we got the carbon chain, then still it stays amide. Okay. Yes, the peptide bond is only this thing, this thing. This thing is a peptide bond. It doesn't matter whether the nitrogen is further bonded to 2 hydrogens or the 2 alkyl chains. That is the most simplest amide with the 2 hydrogens. Okay. And then the last one is nitrile, where a carbon has a triple bond with nitrogen. Okay. Now, if we go over their general formulas, so this one is CnH, Cn, H2n plus 1, plus 1 NH2. Plus 2 over here, Cn, H2n plus 1 NO. And over here, it's Cn, H2n plus 1 Cn. Okay, just give me a minute. For example, if it's CH3, so C2, it's CnH2n plus 2 NO. C. That's what I just worked on it. For example, if here CH3 is written, so what will be the value of N? 2. So 2 times 2 plus 2. No, I was right earlier. It's 2 and plus 1 and NM. Okay. Now, their general names. Their general name is alkanamine. Then the general name is alkanamide, alkannitrile. And in the last one, we also use the value of N is going to be one carbon less than the total carbons. Because there are two carbons in the formula. See, there's one. So if it's propane nitrile, so the value of N is going to be 2, not 3, because the third carbon is already there. Is this clear? Yes, I will share it. Okay. So for a amine, what I'm going to do, I'm going to put a N and forms 2 bonds with 2 hydrogens. For amide, I put the double bond O and then NH2. For nitrile, it's C triple bond N. So here this is the functional group. Here this is the functional group. And here this is the functional group. Okay, if the examiner specifically asks you about the primary amine, then this whole thing is considered as the functional group. Is this clear? No. Just go over these functional groups quickly, because now I'm going to give you a few structures and you guys need to identify which functional groups are there in those structures. So just go over the functional groups with the names quickly. Yes, Ahmed, will you be able to figure out the functional groups in the given structures? Yes, Ridwan. Yes, Laiba. One minute. Okay. Mm. Yes, which functional groups are there in this structure? Ahmed. Yes, Laiba, Kirsha, and Ridwan, anyone can identify? There are, okay, how many functional groups are there? There is a one functional group that is really visible over here. And the other one is, if you see, CHO, which is aldehyde. Aldehyde. So over here, this is aldehyde. Is this understandable? Yes, Ridwan.
Yes, sir.
Yes, Laiba, and yes, Kirsha, is this clear?
Yes, sir.
So it's aldehyde, and this one is alkene. Okay. Now, 1 minute. Ahmed, identify the functional groups in this. Very good. How many carboxylic acids are there? Okay. So see, this is carboxylic acid, this is carboxylic acid, this is carboxylic acid. Now, what is this one?
Aldehyde.
Yes? Laiba, I can't hear you properly. No. Yes, which functional group is the third one? Ridwan.
Sir, methyl group.
Why you guys are not audible? Yes, Ridwan, can you speak again?
Sir, methyl group.
No, methyl is not. Did we study any methyl functional group? Yes, Mariam. You. So, okay, if you try to open it, see.
Sir, ester.
Yes, can you repeat, Ridwan?
Sir, I was saying ester.
Yes, very good. It's ester. So, see, O, then C double bond O, and then CH3. And this O is actually bonded over here. So that makes it ester. So ester is the one in which the student find the most difficulty to identify. Yes. See the C double bond O, and that is bonded to O. Okay. So one more. 1 minute. 1 minute. Let me look for one. Okay, class. This one. Hmm? This is one functional group. This is the other functional group. Very good. So it contains nitrile, alkene, and ester. Yes, is this clear to all of you? Just do this one. So, okay, so every corner is actually representing the carbon, the C. So it means there is a C over here. That's a bond. So C, C, that's a double bond. Very good. One is alkene. No, it's not ethene, it's alkene. What is this one? And what is this one? Yes. Ridwan, Laiba, Kirsha. One is alkene. What is the another functional group over here? One carbonyl, there are two. It's ketone. Aldehyde has a C double bond or bonded to hydrogen. But either C double bond or bonded to carbon on both sides. See, here it's on both sides there is a carbon. So that is ketone. Okay. So now next class on Friday, 3:30 to 4:30. And Sunday, 10:30 to 12. Okay. So see you everyone in the next class. Take care. Allah Hafiz.